Videoconferencing is the conduct of a video conference by a set of telecommunication technologies which allow two or more locations to communicate by simultaneous two-way video and audio transmissions. It has also been called visual collaboration, and is a type of groupware. Videoconferencing differs from video phone calls in that it's designed to serve a conference or multiple locations rather than individuals. It is an intermediate form of video telephony, first used commercially in Germany during the late 1930s and later in the United States during the early 1970s as part of AT&T's development of picture phone technology. With the introduction of relatively low-cost, high-capacity broadband telecommunication services in the late 1990s, coupled with powerful computing processes and video compression techniques, video conferencing has made significant inroads in business, education, medicine and media history. Video conferencing uses audio and video telecommunications to bring people at different sites together. This can be as simple as a conversation between people in private offices or involve several sites in large rooms at multiple locations. Besides the audio and visual transmission of meeting activities, allied video conferencing technologies can be used to share documents and display information on whiteboards. Simple analog video phone communication could be established as early as the invention of the television. Such an antecedent usually consisted of two closed-circuit television systems connected via coax cable or radio. An example of that was the German Reich Postzentralamt video telephone network serving Berlin and several German cities via coaxial cables between 1936 and 1940. During the first manned spaceflights, NASA used two radio-frequency video links, one in each direction. TV channels routinely use this type of video telephony when reporting from distant locations. The news media were to become regular users of mobile links to satellites using specially equipped trucks, and much later via special satellite video phones in a briefcase. This technique was very expensive, though, and could not be used for applications such as telemedicine, distance education, and business meetings. Attempts at using normal telephony networks to transmit slow-scan video, such as the first systems developed by AT&T Corporation, first researched in the 1950s, failed mostly due to the poor picture quality and the lack of efficient video compression techniques. The greater 1 MHz bandwidth and 6 MB/s per second bit rate of the picture phone in the 1970s also did not achieve commercial success, mostly due to its high cost, but also due to a lack of network effect. With only a few hundred picture phones in the world, users had extremely few contacts they could actually call to, and interoperability with other video phone systems would not exist for decades. It was only in the 1980s that digital telephony transmission networks became possible, such as with ISDN networks, assuring a minimum bitrate for compressed video and audio transmission. During this time, there was also research into other forms of digital video and audio communication. Many of these technologies, such as the media space, are not as widely used today as video conferencing but were still an important area of research. The first dedicated systems started to appear in the market as ISDN networks were expanding throughout the world. One of the first commercial video conferencing systems sold to companies came from Ptz Corp, which had an initial public offering in November 1984. In 1984, Concept Communication in the United States replaced the then £100, $100,000 computers necessary for teleconferencing, with a $12,000 circuit board that doubled the video frame rate from 15 up to 30 frames per second, and which reduced the equipment to the size of a circuit board fitting into standard personal computers. The company also secured a patent for a codec for full-motion video conferencing, first demonstrated at AT&T Bell Labs in 1986. Videoconferencing systems throughout the 1990s rapidly evolved from very expensive proprietary equipment, software and network requirements to a standards-based technology readily available to the general public at a reasonable cost. Finally, in the 1990s, Internet Protocol-based video conferencing became possible, and more efficient video compression technologies were developed, permitting desktop or personal computer-based video conferencing. In 1992, CU-SEAM was developed at Cornell by Tim Dorsey al. In 1995, the first public video conference between North America and Africa took place, linking a techno fair in San Francisco with a techno rave in Cyber-Delhi in Cape Town. At the Winter Olympics opening ceremony in Nagano, Japan, Seiji Ozawa conducted the Ode to Joy from Beethoven's Ninth Symphony simultaneously across 5 continents in near real time. While video conferencing technology was initially used primarily within internal corporate communication networks, one of the first community service usages of the technology started in 1992 through a unique partnership with Ptz and IBM corporations, which, at the time, were promoting a jointly developed desktop-based video conferencing products known as the PCS-1. Over the next 15 years, Project Diane grew to utilize a variety of video conferencing platforms to create a multi-state cooperative public service and distance education network consisting of several hundred schools, neighborhood centers, libraries, science museums, zoos and parks, public assistance centers, and other community-oriented organizations. In the 2000s, video telephony was popularized via free internet services such as Skype and ItChat, web plugins and online telecommunication programs that promoted low-cost, albeit lower quality, video conferencing to virtually every location with an internet connection. In May 2005, the first high-definition video conferencing systems, produced by Life-Size Communications, were displayed at the Interop trade show in Las Vegas, Nevada, able to provide video at 30 frames per second with a 1280 by 720 display resolution. Polycom introduced its first high-definition video conferencing system to the market in 2006. As of the 2010s, high-definition resolution for video conferencing became a popular feature, with most major suppliers in the video conferencing market offering it. Technological developments by video conferencing developers in the 2010s have extended the capabilities of video conferencing systems beyond the boardroom for use with handheld mobile devices that combine the use of video, audio and on-screen drawing capabilities, broadcasting in real time over secure networks, independent of location. Mobile collaboration systems now allow multiple people in previously unreachable locations, such as workers on an offshore oil rig, the ability to view and discuss issues with colleagues thousands of miles away. Traditional video conferencing system manufacturers have begun providing mobile applications as well, such as those that allow for live and still image streaming. Technology. The core technology used in a video conferencing system is digital compression of audio and video streams in real time. The hardware or software that performs compression is called a codec. Compression rates of up to 1 to 500 can be achieved. The resulting digital stream of 1s and 0s is subdivided into labeled packets, which are then transmitted through a digital network of some kind. The use of audio modems in the transmission line allow for the use of Ptz, or the plain old telephone system, in some low-speed applications, such as video telephony, because they convert the digital pulses from analog waves in the audio spectrum range. The other components required for a video conferencing system include video input, video camera or webcam, video output, computer monitor, television or projector, audio input, microphones, CD, DVD player, cassette player, or any other source of preamp audio outlet, audio output, usually loudspeakers associated with the display device or telephone. Data transfer, analog or digital telephone network, LAN or Internet. Computer, a data processing unit that ties together the other components, does the compressing and decompressing, and initiates and maintains the data linkage via the network. There are basically two kinds of video conferencing systems. Dedicated systems have all required components packaged into a single piece of equipment, usually a console with a high-quality remote-controlled video camera. These cameras can be controlled at a distance to pan left and right, tilt up and down, and zoom. They became known as Ptz Cameras. The console contains all electrical interfaces, the control computer, and the software or hardware-based codec. Omnidirectional microphones are connected to the console, as well as a TV monitor with loudspeakers or a video projector. There are several types of dedicated video conferencing devices. Large group video conferencing are non-portable, large, more expensive devices used for large rooms and auditoriums. Small group video conferencing are non-portable or portable, smaller, less expensive devices used for small meeting rooms. Individual video conferencing are usually portable devices, meant for single users, have fixed cameras, microphones and loudspeakers integrated into the console. Desktop systems are add-ons to normal PCs and laptops, transforming them into video conferencing devices. A range of different cameras and microphones can be used with the codec, which contains the necessary codec and transmission interfaces. Most of the desktop systems work with the H323 standard. Video conferences carried out via dispersed PCs are also known as e-meetings. These can also be non-standard, Microsoft Link, Skype for Business, Google Hangouts, or Yahoo Messenger, or standards-based, Cisco Jabber. WebTC platforms are video conferencing solutions that are not resident by using a software application but is available through the standard web browser. Solutions such as Adobe Connect and Cisco WebEx can be accessed by going to a URL sent by the meeting organizer, and various degrees of security can be attached to the virtual room. Often the user will be required to download a piece of software, called an add-in, to enable the browser to access the local camera, microphone and establish a connection to the meeting. Conferencing layers. The components within a conferencing system can be divided up into several different layers. User interface, conference control, control or signal plane, and media plane. Video conferencing user interfaces can be either graphical or voice responsive. Many in the industry have encountered both types of interfaces, and normally graphical interfaces are encountered on a computer. User interfaces for conferencing have a number of different uses. They can be used for scheduling, setup, and making a video call. Through the user interface, the administrator is able to control the other three layers of the system. Conference control performs resource allocation, management and routing. This layer, along with the user interface, creates meetings or adds and removes participants from a conference. Control plane contains the stacks that signal different endpoints to create a call-in, or a conference. Signals can be, but aren't limited to, H323 and session initiation protocol protocols. These signals control incoming and outgoing connections as well as session parameters. The media plane controls the audio and video mixing and streaming. This layer manages real-time transport protocols, user datagram packets and real-time transport control protocol. The RTP and UDP normally carry information such the payload type, which is the type of codec, frame rate, video size and many others. RTCP, on the other hand, acts as a quality control protocol for detecting errors during streaming. Multipoint video conferencing. Simultaneous video conferencing among three or more remote points is possible by means of a multipoint control unit. This is a bridge that interconnects calls from several sources. all parties call the MCU, or the MCU can also call the parties which are going to participate, in sequence. There are MCU bridges for IP and ISDN-based video conferencing. There are MCUs which are pure software, and others which are a combination of hardware and software. An MCU is characterized according to the number of simultaneous calls it can handle, its ability to conduct transposing of data rates and protocols, and features such as continuous presence, in which multiple parties can be seen on screen at once. MCUs can be standalone hardware devices, or they can be embedded into dedicated video conferencing units. The MCU consists of two logical components: a single multipoint controller, and multipoint processors, sometimes referred to as the mixer. The MC controls the conferencing while it is active on the signaling plane, which is simply where the system manages conferencing creation, endpoint signaling and in-conferencing controls. This component negotiates parameters with every endpoint in the network and controls conferencing resources. While the MC controls resources and signaling negotiations, the MP operates on the media plane and receives media from each endpoint. The MP generates output streams from each endpoint and redirects the information to other endpoints in the conference. Some systems are capable of multipoint conferencing with no MCU, standalone, embedded or otherwise. These use a standards-based H323 technique known as decentralized multipoint, where each station in a multipoint call exchanges video and audio directly with the other stations with no central manager or other bottleneck. The advantages of this technique are that the video and audio will generally be of higher quality because they don't have to be relayed through a central point. Also, users can make ad hoc multipoint calls without any concern for the availability or control of an MCU. This added convenience and quality comes at the expense of some increased network bandwidth, because every station must transmit to every other station directly. Video conferencing modes. Video conferencing systems use several common operating modes: voice-activated switch, continuous presence. In VAS mode, the MCU switches which endpoint can be seen by the other endpoints by the levels of one's voice. If there are 4 people in a conference, the only one that will be seen in the conference is the site which is talking. The location with the loudest voice will be seen by the other participants. Continuous presence mode displays multiple participants at the same time. The MP in this mode takes the streams from the different endpoints and puts them all together into a single video image. In this mode, the MCU normally sends the same type of images to all participants. Typically, these types of images are called layouts, and can vary depending on the number of participants in a conference. Echo cancellation. A fundamental feature of professional video conferencing systems is acoustic echo cancellation. Echo can be defined as the reflected source wave interference with new wave created by source. AEC is an algorithm which is able to detect when sounds or utterances re-enter the audio input of the video conferencing codec, which came from the audio output of the same system, after some time delay. If unchecked, this can lead to several problems including the remote party hearing their own voice coming back at them, strong reverberation, which makes the voice channel useless, and howling created by feedback. Echo cancellation is a processor-intensive task that usually works over a narrow range of sound delays. Cloud-based video conferencing. Cloud-based video conferencing can be used without the hardware generally required by other video conferencing systems, and can be designed for use by SMEs, or larger international companies like Facebook. Cloud-based systems can handle either 2D or 3D video broadcasting. Cloud-based systems can also implement mobile calls, VoIP, and other forms of video calling. They can also come with a video recording function to archive past meetings, technical and other issues. Computer security experts have shown that poorly configured or inadequately supervised video conferencing system can permit an easy, virtual, entry by computer hackers and criminals into company premises and corporate boardrooms via their own video conferencing systems. Some observers argue that three outstanding issues have prevented video conferencing from becoming a standard form of communication, despite the ubiquity of video conferencing-capable systems. These issues are: Icontact. Icontact plays a large role in conversational turn-taking, perceived attention and intent, and other aspects of group communication. While traditional telephone conversations give no eye contact cues, many video conferencing systems are arguably worse in that they provide an incorrect impression that the remote interlocutor is avoiding eye contact. Some telepresence systems have cameras located in the screens that reduce the amount of parallax observed by the users. This issue is also being addressed through research that generates a synthetic image with eye contact using stereo reconstruction. Telcordia Technologies, formerly Bell Communications Research, owns a patent for eye-to-eye video conferencing using rear projection screens with the video camera behind it, evolved from a 1960s U.S. military system that provided video conferencing services between the White House and various other government and military facilities. This technique eliminates the need for special cameras or image processing. Appearance consciousness. A second psychological problem with video conferencing is being on camera, with the video stream possibly even being recorded. The burden of presenting an acceptable on-screen appearance is not present in audio-only communication. Early studies by Alphonse Japanis found that the addition of video actually impaired communication, possibly because of the consciousness of being on camera. Signal latency. The information transport of digital signals in many steps need time. In a telecommunicated conversation, an increased latency larger than about 150 to 300 milliseconds becomes noticeable and is soon observed as unnatural and distracting. Therefore, next to a stable large bandwidth, a small total round-trip time is another major technical requirement for the communication channel for interactive video conferencing. The issue of eye contact may be solved with advancing technology, and presumably the issue of appearance consciousness will fade as people become accustomed to video conferencing.